Hello, 9th graders! This is Teleradyo Eskwela, Tara na! Welcoming you to Mathematics 9. We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your Teleradyo host, Teacher Rosella A. Deliva from Tagum City National High School. Stay tuned and be a one-of-a-kind math talino student. We would also like to thank our radio partner, Hope Radio 107.1 DXHS, where we are airing our lessons for junior high school. Thank you for your generosity. And today, you will be learning another exciting topic, a lesson, particularly in grade 9 mathematics. Quarter 2, Module 4, Laws Involving Integral Exponents. Before we begin, I would like you to get your modules, your notebook, and your pen, and be comfortably seated in the comfort of your homes. This topic will be brought to us today by our radio teacher, Teacher Melissa P. Boko from Tagum City National High School.
Hello there, students. I hope you are all safe and well wherever you are while listening to our program. Now that you are all settled in your homes, bring out your pens and notebooks and your learning materials, specifically your Mathematics 9, Quarter 2, Module. Today, we will be learning about laws involving integral exponents. Here are our learning objectives for today. At the end of this lesson, the students are expected to apply the laws involving positive integral exponents to zero and negative integral exponents, and simplify expressions that involve integral exponents. One of the most common real-world applications of exponents involve taking measurements and calculating multidimensional quantities. For instance, when you calculate the area of a garden bed using feet, you should provide the solution in square feet or feet squared using an exponent. In addition, exponents are especially important in calculating compound interest because the amount of money that is earned and compounded depends on the exponent of time. Mostly, the average people don't use exponent except when it comes to careers in finance, computer engineering and programming, science and accounting. Exponents give us a very convenient way of writing very large and very small numbers. They are also very handy for making algebra easier because it is more compact. In this episode, you will develop your skills in simplifying algebraic expressions with numerical power by applying different laws of exponents. Before we'll proceed to our topic, let us first have a review on how to simplify exponents. Say you are given the expression 3 raised to 4, which number is the base? What about the exponent? In the given expression, 3 here is our base and 4 is our exponent. Or it can also be called power or index. Exponent is the small number written above the number that indicates how many times you will multiply the base by itself. In other words, 3 raised to 4 can be read as 3 to the power of 4 or 3 raised to 4. And when we simplify the expression 3 raised to 4, which would mean 3 times 3 times 3 times 3, which would give you the result of 81. Number 2. What about the quantity of negative 3 raised to 2? What is your answer? The quantity of negative 3 times the quantity of negative 3 is positive 9. Number 3. Simplify negative 4 raised to 2. The answer is negative 16. Now let us learn the concept of laws of exponents that explains how it is applicable in simplifying algebraic expression with integral exponents. First, we have the so-called product rule. Let x be any real number and let m and n be positive integers. Then, x raised to m times x raised to n is equal to x raised to m plus n. When we multiply two powers that have the same base, add the exponents. Example number 1. X squared times x raised to the power of 3. Take note, the bases are the same, so you can add the exponents. Then you have x raised to 2 plus 3 equals x raised to 5. Example number 2. 3 squared times 3 raised to the power of 3 is equal to 3 raised to 2 plus 3 equals 3 raised to 5. Then the simplified form is 243. Example number 3. Simplify the quantity of 4x raised to 3 times y raised to 2 times the quantity of 3x raised to 6 times y. In this problem, you multiply the numerical coefficients 4 and 3, then add only the exponents with the same variable. So, you will have 12x raised to 9, y raised to 3. Take note, for the product rule, do not multiply the exponents. Always observe the rule of signs when adding the exponents. Now let's proceed to quotient rule. Let x be any real number and let m and n be positive integers. Then, x raised to m divided by x raised to n is equal to x raised to m minus n. Divide the expressions. When two bases are the same, just copy the base and subtract the exponents. For the quotient rule, please take note, do not divide the exponents. Apply the rule of signs in subtracting negative exponents. The numerical coefficients should be simplified to the lowest term if possible. Say we have example number 1. 6 raised to 5 divided by 6 raised to 3. Since the bases are the same, so you can subtract the exponents. So you will have 6 raised to 2 or 36. Example number 2. 15 times b raised to 5 divided by 3 times b raised to 3. Divide 15 and 3, then subtract the exponents of the base b. Thus, will give you 5 times b raised to 2 or 5b squared. Now let's discuss the power rule. Let x be any real number and let m and n be positive integers. Then the quantity of x raised to m raised to n is equal to x raised to mn. When an expression is enclosed in a grouping symbols like parentheses and raised by an integral exponent, the exponent inside will be multiplied by the exponent outside. The numerical coefficient of the expression will also be raised by the exponent outside the expression. Say we have the quantity of 2a squared raised to 3 is equal to 2 raised to 3, then a raised to 2 times 3. So you will have 8a raised to 6. Another example is the quantity of 2x over 3y squared raised to 3 is equal to the quantity of 2x raised to 3 over the quantity of 3y squared raised to 3. And the simplified form will be x times x raised to 3 over 27y raised to 6. So this is an example of a quotient of a power. Next will be the zero exponent rule. Let x be any real number except 0. X raised to 0 is equal to 1. Expressions with an exponent of 0 will always be equivalent to 1. For our examples, say we have 255 raised to 0 is equal to 1. The quantity of 3a, b raised to 4, c cubed, raised to the power of 0 is equal to 1. 6xy cubed z raised to 0 is equal to 6xy cubed times 1. So you will have 6xy cubed. Remember, z raised to 0 is only the variable that is raised by 0 and is equal to 1. Next, we have the negative exponents. A raised to the negative n is equal to 1 over a raised to n, where a is not equal to 0 and n is a counting number. Some expressions may have negative exponents either in numerator or denominator. It is much easier to simplify expressions when the negative exponents were changed to positive signs. In this case, the law for negative exponents applies and it has an equivalent value. Get the reciprocal of the base and change the sign of the exponent to positive. Take note, when the base of a negative exponent is not a fraction, always assign 1 as a numerator when reciprocating the base. For example, if we have x raised to the negative 3 is equal to 1 over x raised to 3. Let's consider another example. 4 raised to the negative 3 is equal to 1 over 4 raised to 3, which will give you the simplified answer 1 over 64. Now let us have a short activity to determine what you have learned in today's lesson. I want you to get your notebook, your pen, and prepare yourself with a focused mind because we will have now our assessment. I will be asking only 3 questions for these tests. There will be no choices, so you have to be very quick in providing the answer. Are you ready? Let us begin. Simplify the following expressions and write your answers with positive exponents. Number 1, simplify the quantity of 9x raised to 0. Simplify the quantity of 9x raised to 0. You have 5 seconds to answer. The answer is 1. What mathematical concept did you apply? Alright, in this expression, we use the zero exponent rule. We will now proceed to question number 2. Simplify 25x raised to 4 over 5x raised to 7. Again, simplify 25x raised to 4 over 5x raised to 7. You have 5 seconds to answer. Did you get it correctly? The answer is 5 over x raised to 3. How did you do it? Using the quotient rule. We divide first 25 and 5, then we subtract the exponents since it has the same basis. Then we come up with x raised to the negative 3, and since we have also negative exponent rule, therefore our final answer will be 5 over x raised to the power of 3. I know you could do it. Way to go! We will now proceed to our third and final question. Simplify the quantity of 5 times x times y raised to the negative 4 times the quantity of 2 times x raised to 3 times y raised to 2. Simplify the quantity 5 times x times y raised to negative 4 times the quantity of 2 x raised to 3 times y raised to 2. You have 10 seconds. What is the correct answer? The answer is 10x raised to 4 over y raised to 2. I hope that you get all the answers correctly. If you did not get all the items right, there is nothing to worry. Remember that there is always room for improvement. So make sure that you practice by solving similar problems at home, as it is the key to solving mathematics. If you wish to review this episode, you may watch it again. And that wraps up our lesson today. For your assignment, answer Let Us Enhance on page 10 on your Quarter 2, Module 4. Kindly put your answers in your notebook for checking, at the same time set in the weekly home learning plan. This is all for today. Stay tuned next week for our discussion on simplifying expression with rational exponents. Let us turn you over now to Teacher Ella. Until next time.
Thank you, Teacher Melissa. That ends our lesson for today. For you to understand our topic further, you may do the exercises provided in your modules. You may also have an advanced study of your topics to prepare yourself for the next lesson. Remember that the key to mastering mathematics is constant and diligent practice. Please make sure to be with us next session, only here at School on the Air program of the Department of Education. This has been Teacher Rosala A. Daliva, your radio host. Keep safe, everyone!
TV High, dito sa City High. Makisabay, matuto't maglakbay sa TV High.